Hey, this is Dr. B, and let's take a look at methods to make organic substances. We call the overall analysis of how we're going to make something retrosynthetic, because you usually work your way backwards. In this particular series of slides, we've shown you how to turn alkanes into a whole bunch of different functional groups. So we have a bit of an arsenal of chemical reaction types at our disposal, and let's learn how to use them. We can turn an alkane into a haloalkane by a free radical halogenation process, typically initiated by UV light. If we substitute that haloalkane with hydroxide, we can turn it into an alcohol. If we react that alcohol with acid, we can eliminate it down to an alkene. If we take that alkene and react it with a hydrogen halide, we can do asymmetrical substitution reactions and turn that back into a haloalkane. Instead, if we just wanted to make a plastic, we could hit that alkene with UV light and polymerize it. When we're at the alcohol stage, we could bring it up to the aldehyde. That's an oxidation using a mild oxidation reactant such as potassium dichromate. If we wanted to bring it back down to the alcohol, we'd have to hit it with hydride, and sodium borohydride is a mild reactant for that. On the other hand, if we want to take the alcohol, that's going to show up in a second. There it is. On the other hand, if we wanted to take the alcohol and oxidize it right past the aldehyde or ketone and all the way to the carboxylic acid, we could do so using potassium permanganate, a much stronger oxidizing reagent. And by the way, if it was a secondary alcohol, you hope you recognize that you wouldn't make an aldehyde. You could make a ketone that way. Now, if you have a carboxylic acid, there's a couple things you could do with it. We can bring it right back down to the alcohol if we wanted to, using a very strong hydride source, such as lithium aluminum hydride. That's H-, a reducing agent. And you can combine those alcohols with the carboxylic acids to make esters. So that's a whole bunch of things we can do. And let's just give one example of a retrosynthetic analysis. Suppose we wanted to make some ethyl acetate, which is sort of the essence of banana. And all we have to work with is ethanol and some simple reagents for modifying it. How are we going to do that? Well, retrosynthetically, the ester, right, comes from acid and alcohol. And it is ethanol from which it's derived. We just need acetic acid. And we can oxidize ethanol up to acetic acid. So see how we work backwards and figured out how do we do this? It should take place only in 2 steps. Start with your ethanol, hit it with permanganate all the way up to acetic acid, add some of that alcohol back, esterify it, lose some water. You'll need a H+ source to do that, and lo and behold, you have your ethyl acetate. This is an introduction to retrosynthetic analysis.